This is 1989 BC3. We're looking at the function e to the x times cosine of x with a domain 0 to 2 pi. You need to find the absolute minimum and maximum, find the intervals on which f is increasing, and find the x-coordinate of each point of inflection on the graph. Our mins and maxes are going to be where our first derivative is equal to 0 and when it switches from negative to positive or positive to negative. So our first derivative is negative e to the x sine x plus e to the x cosine x. If we factor out an e to the x, we'll get e to the x times cosine x minus sine x. So now we find our zeros. Since e to the x can never be 0, we're just looking at the cosine x minus sine x. So when we set that equal to 0, we get sine x equals cosine x, which means our x's would be pi over 4 and 5 pi over 4. Now since we have a closed interval, we have to test the endpoints too. If you look over to the left, you see I have a little table. We're looking at 0, pi over 4, 5 pi over 4, and 2 pi. If we plug those into our first derivative, we'll get 1, square root of 2 over 2 e to the pi over 4, negative square root of 2 over 2 e to the 5 pi over 4, and e to the 2 pi. So now we see that our absolute minimum is 5 pi over 4, negative square root of 2 over 2 e to the 5 pi over 4, and our absolute max is 2 pi e to the 2 pi. Part B asks for when the function is increasing, so we're going to look at the first derivative when it's greater than 0. Use your endpoints and critical points learned from Part A to see that the function is increasing on the interval 0 to pi over 4 and 5 pi over 4 to 2 pi. Part C asks for the inflection points, so we're going to look at the second derivative at 0. So our first derivative, just reminding you, is e to the x times cosine x minus sine x. So the second derivative would be, use your product rule, e to the x times negative sine x minus cosine x plus e to the x times cosine x minus sine x. Now if you FOIL that out, you'll get negative e to the x sine x minus e to the x cosine x plus e to the x cosine x minus e to the x sine x. And you'll see that negative e to the x cosine x and positive e to the x cosine x will cancel out, leaving you with negative 2 e to the x sine x. If you set that equal to 0, you'll get x equals 0, pi, and 2 pi. Since 0 and 2 pi are our endpoints, our inflection point would be x equals pi.